Hey everyone, we're back. So this will be the second half of our video lecture for section 13.2 here in Calculus 3 class. The first one was about finding limits of two variable functions. Now we're going to talk about continuity. So what does it mean to be a continuous function? So the first definition is a function of two variables is continuous at a point if on an open region. Okay, think of open neighborhood as a region. We have that the limit not only exists but is equal to the function value. So the limit is x, y approaches x0, y0, f of x, y will be equal to what you get when you plug the number in. Okay, so clearly the function has to be defined at that point. But not only that, the limit has to be there. You can't have like this be different than the limit. That means it's open, or that means it's continuous. Continuous on a whole region means f(x,y) is continuous at all points on in the region. And that little one symbol is not really epsilon. It's symbol is an element of or is in. Okay, and just like the limit laws were consistent between single variable and multivariable functions, so are the rules and theorems about arithmetic of functions. Gives you arithmetic of continuous functions gives you continuous functions. So that is, say, if k is a real number and f and g are continuous, then so are k times f, f plus or minus g, f times g, f over g if, oops. If g of x0, y0 is not 0. Okay. And then there's another one about composition. So this, I'm not talking about the domain and range has to be correct for the composition to still be a continuous function. But basically, if you have continuous functions, you can do arithmetic on them and remain continuous, which means that this function here is continuous on all of R2 because it is the composition of the polynomial x squared plus y squared, which is definitely continuous for all x, y. And sine of such a thing is continuous, smooth. Multiplied by k is 1/2. It doesn't change anything. Anyway, this is continuous everywhere, right? So maybe I'll pick that in red, like to make it analogous to above. Okay. What about this one? Well, this one's continuous on everywhere except the origin. That's because that's the only place where the denominator is equal to 0, right? Because x squared plus y squared can only be equal to 0 when both x and y are 0. And so that quotient rule above would only apply there. So if you wanted to, I don't know, you wanted to, that's the punctured plane. That's what it's called. Okay. What about this guy? So when is this continuous? This is continuous wherever the denominator is not zero, right? So this is it's continuous on R2, and then you take away the set where y minus x squared is equal to 0. So if I were to draw this picture, okay, y minus x squared equals 0 is the parabola, right? So we have that parabola, we take that parabola away, and what's left is everything where the function is continuous. Okay. Now this next one, the denominator is never 0, right? So this is continuous on all of R2. This is because x squared plus 1 is always at least equal to, or at least 1. So it's never 0. Okay. And there's really no restriction on y anyway. What about this item number 5? Once again, we can't have a 0 and a denominator. So this is the x-axis. So if y is 0, that's the x-axis, right? So if I were to draw this graph of the region that where it's continuous, I would just take away where y is 0 and then color in everybody else. All right, lastly, what about the arctangent? Well, the arctangent of h, or of x, arctangent of x, it looks like this. It's continuous everywhere, right? It just doesn't have the range only goes from -1 to 1. Or sorry, negative pi over 2, pi over 2. Right? So the only issue, so the arctangent's not a problem. The only issue is the denominator. And so this is continuous on all of R2, except where the denominator is 0. But that is when y equals -1 over x, right? So if I were to sketch this thing. -1 over x looks like this. Dots. And then turns out everywhere else we have no issues. Okay. So that's it for section 13.2. If you have any questions, send me an email. Bye, y'all.